So I put the link to the doc. So if you could sign in, I'm running a little late here, so I'm a little behind. All right, let me share my screen. Okay. So let me just start here. So the service catalog, just kind of want to bring everybody up to speed what we ran into at the microservices. So one of the things that when we went through and built the microservices, we first started out, all the microservices were Flask applications. And from there, we went from a Flask application to adding in some additional functionality like a pie breaker to deal with the connections issue when the container starts up, that if we have a bad database connection, that we go into this retry logic using pie breaker. And then Crum added in, found some connection pooling through SQL Alchemy. And we added that in, and everything was working great in our local environment. So beginning of the week, we started testing. We got the builds done with the Docker containers and started testing the Flask application with PieBreaker, SQL Alchemy, all those things. And what ended up happening was we ended up getting these weird errors with a conflict between there's a threading program called Greenlit. And the threading program, that module for the unicorn, which is what we run the Flask application under the Docker container. That's like the production version, the way you run it. That required 0.4.17. And then the SQL Alchemy wanted 1.1.1, the latest version. And there was no way to kind of work around it as part of that to get things to work. So we had to take out Flask and go to a separate, different runtime environment. So the Flask Fast Api. So we needed to remove Flask and add in and replace with so this actually ended up being a kind of like a blessing in disguise. Fast API is 200% faster than the unicorn and the Flask application. Also, we solved the version conflict on the Greenlit. And also it ended up simplifying the code. So let me show you what we ended up with. Oh, this one. So things ended up being very similar as far as like, the SQL didn't need to change. One of the things that we ended up changing was the entry point. Instead of the Flask being the entry point, we have Fast API. The pie breaker we were able to remove, and some of the other modules that we needed around the Flask version of it. This one actually can come out too, because it's imported through the SQL Alchemy now. So one of the things we'll see is we still have, getting the environment, the database connection. Karam, one thing I needed to change from the connection pool that you were using was to go ahead and use the create engine statement, which internally creates the queued tool, which is what you were doing. For some reason, it like built up the SQL environment better as part of that process. So that's what we ended up having to do on that level from the database perspective. One of the things with the Fast API is we can set up classes of what the returned objects look like. So in the case of the health endpoint that we have, we can actually list the responses, and this is where our Swagger documentation actually is being defined now. So if we look at the health, we basically, our description, our examples, those type of things are all based on, are going to be pushed over to Swagger, and Swagger is internally built into Fast API, which is the other part that we're able to remove up at the top. We used to have a Swagger piece, importing some of the Swagger UI and setting up some of the Swagger information. So I just ended up moving some of the Swagger details out of this swagger.yaml over into the code here itself. One of the good things on that front is, everything's in one place. So if you change or add a response, that you can just change it in the code. You don't have to go to the Swagger file and do it in two places. So our health connection, it used to be a class, was the endpoint. So this is where we define the endpoint here. And in the past, it was a class, and instead we just made it over to an async. You'll see in the Fast API documentation that you'll have different parameters that you can pass into the function, so you can get access to specific parts of the underlying like HTTP model. So in this case, we're interested in the response part of the code. So the response part, because we're going to go ahead and set like the return code. So basically, one of the other things that I found, this was late last night, was we needed to use a with statement for doing our queries. The with statement in Python does some interesting things. So when you specify a with, and you can do this like with files and other things, basically when you end up going out of scope, it's like a built-in try finally type of world that's there. And when it goes out of scope, it'll go ahead and do what it wants to do as far as like closing connection, closing cursors, those type of things. So that was one of the nice things that I found that we needed to use with the new connection pooling. Instead of the explicit connection pooling that Chrome set up, the implicit one. What was happening in the previous iteration of the database connection, it would do this weird, if you let it be idle for like 5 minutes and then you try to throw a transaction at it, it would go and say that this connection rollback was already closed. And it was like the connection pooling was all confused. And I think what was happening was we weren't explicitly closing all the connections and cursors in the right order. So this with syntax kind of solves that for us, and also simplifies the code dramatically. So we'll keep going here. So like on here, we could actually, after this, it's not necessarily a mandatory, but we could do a cursor.close here. This will actually happen once we go out of the scope of the width. So that's one of those things that it kind of helps us with the cleanup process. Here, we're going to go ahead and return our status with the up and service name. Now you'll see with the response that we've set up here. Let me get rid of this at the bottom. You can see it all on one page. So we have our status message, and our status message is associated to the model. And when we return a 200, which is a OK, that's going to be the format of the JSON going back. So this is where we're just doing a normal return. Everything's good. So that's where we have our status, which corresponds up to here. And we have our service name, which corresponds up to here. And this is how you do an optional. It's a little bit of a weird syntax, but it definitely works. So this is saying service name is an optional string. If we have a down message, what we're going to do in this case, we're setting the status code to say that the service is unavailable, and then we go ahead and do the same return. And same with if we catch an exception, with the database or basically any exception, we're going to go ahead and return the down message. Any questions on that before I go into a little bit more complicated one with our regular queries? Alrighty. So for validate user, this is one of the other entry points in this one. Basically, it returns a list of integers of the domains, and that's optional. But what we're going to do is return an empty list, just in case if we don't have anything, if it's not asked for, we'll go ahead and just return an empty list as part of that process. So this is the domain model that corresponds up to here. Same thing, we're actually going to have, you'll see here, we just have a regular message class, just for some authorization failure messages. Same type of thing, the examples. Here is the function for validate user for the get. You'll see that we're bringing in the request this time instead of the response. Also, we have an optional string called domains. And then this is replacing the validation that Karam was using with WebArgs. Fast API has the validation in place. So this is just a simple regular expression, but we do have the capability of doing more complex validation if we want to. So basically this is just checking to see if it's a uppercase or lowercase y or n coming in as a parameter. And that one is optional. Then we go through, in this case, we are double checking this is the validating the token that was coming across from the login. So here we actually go and get from the request, we have access to the cookies. We grab the cookie, the token called the cookie called token, do our JWT stuff, and start returning our return codes. Now, if something fails, one of the things that you do to bail out is you raise an HTTP exception and you give it what you want and the message. So you'll see that coming into play when you want to bail out is part of a function. In the health one, it was a little bit different because we didn't really want to throw an exception. We just wanted to tweak the status code. So that's how come in the health check, it's a little bit different. Finally, we'll get into our connection. So we create the connection the same way, do our queries, trying to figure out if the user's validated, get if the domains, if they pass in that YRN, then we do an additional query to go ahead and return the domain list, and then we return our result as part of that. One of the things that you do need to be aware of is you need to, one of the weird things I ran into in the testing is because exception is generic, when you do the raise up here of the exception, and it's in a separate try block, this one here will actually catch that one up there, and you won't return from the method. So what you have to do is you have to catch the HTTP exception from above and re-raise it basically as part of that process. Again, the auto close and all that stuff is going to happen for us. Here we're explicitly closing the connection as part of the process. That's one thing we can do. It's not required to close it up, but the with statement will actually take care of all that for us as part of that process. So let me see if I have this one running. So if we go to, I think it's be. Oh, I don't have it running. So if we want to run it, basically, it's UV corn. It's probably hard to see on my with my font and stuff, but it's UV corn, the Python file, then the app name, and then the port number. It listens on 127.0.1 to have it listen on any to accept connections from any IP. You have to do all zeros. So I'm gonna go ahead and run this. So that's running outside of the container. And if we go ahead and refresh, we get that's our health status. We're up, that's our service name. If we want to look at the docs, we just flip over to docs and we get our Swagger. It's basically open API so this is the health, the examples that we had. So this part here is coming from this part here. So that's where the Swagger is getting picked up at that level. Whoops, go back over here. And then our DOM message, if we want to look at the validate user, it gives us a query with the parameter, kind of the regular expression of what it's expecting, our example for success, example for the failures, and then we can actually get into the schemas themselves. So in this case, this is the domain list, the list of integers. So, and these are the other ones that get built up automatically. So, like I said, I think it was a blessing in disguise to switch things over to Fast API. I think in the long run, we're going to have a little more flexibility and a little cleaner code than on the Flask side. Some of the requirements files, For this one, because it uses JWT, the cryptography and the JWT are actually coming from a base image, and same with Fast API. And the reason why these are coming from the base image is they are need the GCC compiler installed to install those modules. So if you look at the Docker file, we're pulling it from a base that we built, and basically you just go ahead and set up any of the environment variables to pass across. These are the defaults, and then copy your main, your requirements, install it, and you're up and going. If you look at the base, you'll kind of see what I'm talking about. Let me find that real quick, and then I'll Ortelius. Come on. So we're bringing in Alpine 3.8. This is on Docker Hub. We use it as the base builder. We need to build cryptography, and one of the weird side effects with Alpine is it doesn't natively have a Rust compiler in. You don't really need it for some reason, but I don't know. I haven't been able to track down their logic behind cryptography and their dependence on Rust. We just create a working directory that we're going to go ahead and install the modules into. At the OS level, we're going to install the Python, the Postgres development library, all the compilers, the Python development library, can't remember what this one is, and this one is a cryptography library. So basically we go through and build up the compilers that we need, and then we run the pip install that goes through and builds the 4 libraries we need using the GCC compiler. Once that's done, we copy those from the install directory into local, and then we go ahead and add a Postgres library that we need to add in for the runtime, and then we just echo nothing to a startup file. So that kind of gives us what we need as part of that process. One of the things you'll see back in the other one, we actually uninstall pip after we do everything. And the reason why we uninstall pip is because it has a vulnerability in it as part of that process. So that's kind of where we're at. I want to thank Karam and Utkarsh for working on it and putting up with me with changing things around. I kind of been jumping all over the place on this, trying to figure it out, but it didn't really come into play until we started testing under the Docker Kubernetes world. You know, we didn't really see any of that until then. So any questions? Okay, you guys are all pros.
It was just a tutorial on how to get started with Fast API.
What was that, Karam?
So it was a quick tutorial for all of us to getting started with Fast API. Kind of a demo session right now.
Yeah, it's there's not that many, you know, the bulk of the code is the same. You know, like our queries are the same. It's just reworking some of the understanding that you need to move some of the Docker over into, I mean, the Swagger over into the code base. One thing, this is one of our other microservices that you'll see it's very similar. We have all the health checks and stuff like that. Those are identical. One of the things, this is for uploading the Cyclone JSON file and also the safety. Some of the things that when we did this is you can actually write functions to load in examples from files as part of that. But one of the things that on this front that I needed to do was I I had to use this body syntax. This took me a while to figure out. So the body allows you to have access to basically the JSON body, and you tell it you want it to be a dictionary. In the case of the safety one, the safety gets sent across as a list as part of that process. Let me see if I have this one. Where is it? I run these independently so I can debug them. There we go. So come up on 50-50. Oh. So that you'll see where it came up on 127, and it won't let me have access to it. So that's what I was saying with the host. You have to pass in -- host.
Are you sharing screen? We can't see it.
Oh, yeah, let me share it. All right, you should be able to see it now. So I just was starting up the another one of our microservices, and I left off the 00 host. And what ends up happening when I hit the IP address, it says can't be found. So you have to pass in that the zeros in order to expose that over. So here's the post for the JSON, and you can see the example file. So this is actually a file that we load in at execution time. So it gives us a nice full example of what we're expecting. So not just like a small snippet that you put together. It's a real example, which is nice. And you'll see for safety, it's an array of arrays. I don't know why they did it that way, but that's the way it happened. So if you need help getting moved over to, I know Karam and Ukarsh, you're working on flipping these over to Fast API. Just let me know if you run into anything. I can point you in the right direction pretty quick. I think I got a handle on what we need to do at that level.
Interesting. So like it looks simpler, like once you have explained the overall thing. So like we should be able to get started quickly. I think so.
Yeah, it definitely simplifies it. There are, like I said, a few little differences with using like the with statement for blocking, scoping the SQL queries. But once that's in place, it looks good.
Right. And some kudos to Python. I was like a bit sad when we were doing that in class. All those things like connection pooling, validation.
Yeah, and I thought we were, that was an easy way to start, and it was, Flask is pretty popular, but as things evolved, once we got into running things in the Docker container, that part of it, I would have to say, kind of like Docker and Flask don't necessarily play well together. And it just has to do with the way the Flask, the way it seems is like Flask kind of expects you to be running like on a VM, and not really, because you have to put other pieces in place like an Nginx front end proxy and a couple other things to make it production ready. And when you look at it at the Docker level, things are trying to be all those different pieces were trying to be shoved into one container, and it just wasn't working cleanly. So I think from what I could tell in the last couple of days, is the Fast API implementation seems to be tailored more for a production environment.
Yeah, from the code, it seems the same. Like we in Spring Boot, we also have the same thing. Like we get all these query parameters, all those things from in the method only. The endpoint URL, it is getting mapped to the same method, and you can apply the validation directly at place only. So nothing like we used to do in the last part. Like we used to write another piece of code inside. So basically, you can just focus clearly on the business logic, not on the other things.
Exactly. So
I want to ask that I have to learn Flask or Fast API. You told me to learn Flask in the previous meeting.
right, and since the last meeting, that's where we had a pretty big shift. So I will help you with the Fast API part. What I'm going to do is there's a couple other microservices that we need to have updated, Arvind, that aren't on the critical path. So I'm going to work with you on those, getting those up to converted from Flask over to Fast API.
So I have to focus on Fast API now.
It doesn't hurt to have both.
Okay. And I want to start learning Docker. Can I learn it at the same time?
Yes, there. When we made, let me share my screen a little bit real quick. One of the things that we had to do is clean up our Docker files to flip over to the Fast API base. And then if you look at, let me see if I still have it around real quick. Of course, it's not right here. If you look at the Docker file for this one. So like this one, we need to copy in some additional files. So it'll be a little bit of work depending on your the application working with Docker. But as part of the whole process, you want to be able to do a Docker build and run your microservice locally, get it to start up and make sure that you're not getting any like weird dependency issues and stuff like that. So what you'll need to do is go ahead and build locally the Docker image, and then just start it up to make sure that you're not getting any unresolved modules. And the unresolved modules come into play with the requirements file. So when we do the updates, there was basically 3 files that you need to update: the main, the requirements, and the Docker file. And then actually there's going to be a 4th one, which will be the cloud build YAML file. That's where we actually do the builds up on Google. And from there, we'll actually need to, once we're done with that, get the charts cleaned up and ready to go. So that's where we're at. Like I said, the next step will be in the charts world for the Helm charts to make sure we can deploy everything to the Kubernetes cluster correctly.
Okay, thank you.
And what I'm going to do is I'm going to unassign you from one issue and assign you to a couple others. That will be a little bit simpler for you to work on since you're new to the coding. Any other questions? We've run over a little bit. All righty. This is a reminder there. We're going to be meeting this afternoon, my time, 4:30 Mountain Time, 8:30 Australian time, 8:30 a.m. Australian time for the GitOps. with Brad and Amit, and I think we may have Adam Gardner join us and a couple of other new folks from that side around the GitOps. And from there, we will be, I know, Ukarsh, you're looking at some cloud events, and there's some conversations going on around cloud events along with Captain. Those will just keep going on the Discord channel for now, and next week we'll pick those up. Or in 2 weeks, we'll pick those up. Alrighty. Thank you, everybody.
Utkarsh has a question in the chat.
Oh. The base model, I think from what I found is the base model. Let me show you what we're talking about here. So the base model, I think that is used by, that's a REST API. It's coming from Pandanic. It's just how we're importing the Pandanic syntax is being inherited from base model. So what this does, it allows you to kind of in Python, you really don't have variables that you assign a specific type. So you can take a variable X and you can assign it to be equal to 1, and X will be treated as an integer. But then in the next sentence, next line, you can say X equals A, and it'll convert the variable over to a string then. The Pandanic is trying to give a type to a variable, and that allows for validation and transformations on the fly from like JSON and things like that. So that's where the base model and the Pandanic is coming into play, kind of giving you a type for what you're looking for. I don't know on this line, Ukarsh, if you can the model, if it can be something other than a class, if it can be a dictionary. I'm pretty sure that in the Fast API that it has to be a class definition. I hope that answers your question.
One more follow-up in the chat.
Yeah. So that's a good question on so for example, like the status message. So what Ukarsh's question is does it make sense to repeat the definition of status message for every single microservice? And the same thing goes with like the health check. So what it really we need to kind of make a decision is something like this that's kind of like reused across all of the microservices. If we should move that into a Python module and then import it at that level, do an import and set it up that way. So if we need to fix it, we fix it in one place, but then we just go and rebuild everything to consume it. So that's one thing. One question that we need to look at is from a reusability standpoint, how much do we want to get into creating additional smaller utility libraries or modules? Any thoughts? If you guys are willing to stick around, I know we've run over.
Yeah, having this would be have a simpler thing, like for the development purpose. Like you just have to import the thing. I don't have to worry about writing the code.
Right. You'll still have to add a couple lines. We can make it pretty generic, but I'll have to
Instead,
see.
if we can like define a properties file and let define the service name in the properties file, and the model can pick it up from there, that would like simplify things more.
Yeah. So, because there's like the health check. There's another one. Let me go over to this. There's the validation, like here. This code is repeated in every microservice where we go in and validate the user IDs. This could be another method that we just import from a utility standpoint. So
yeah, these are two things like that are getting repeated mostly.
These are the two that I found so far that are pretty common across. Well, there's and then the one last class, just message. So message is for the errors. So when you do a raise, raise an error, it sets the status code of the HTTP request to whatever you're asking, and then it sets a message as detail as part of the JSON return. So your JSON will look like this: detail authorization failed is your message for 401. So that would be some of the things that we could move in there, that class and a couple other ones. The one thing I'm worried about is the one thing we don't want to do is just basically move our monolith over to another, end up putting all this business logic and stuff in a shared, Python module that really, it shouldn't be there. So that's one thing we just have to keep an eye on at that level.
And one more thing, challenge would be that we have to if any version change happens, we have to take care of like where it is getting used and tracking that and updating the same across all the things.
Exactly. Well, that will be, that is actually what this class that we're looking at, this microservice does. It keeps track of those dependencies. So Ortelius will actually keep track of the dependencies for us.
So in order to publish this, like what do you have to do if you want to publish a Python module?
You publish it to PyPy. It is pypi.org. And if you look at this is, I have to go and rename this, but basically this is the command line interface. The package is named I got to rename it to Ortelius. But basically what you need is when you create a Python module, there's a setup.py file. And then you can set up like the project links, the documentation, where the repo is, those type of things, the license. So those type of things are what you set up in your setup file. And then you do a Python, basically it's a build to create the module. And then there's a command called twine that is used to upload it to PyPy.
And what's the format of this particular artifact, like the build that we create?
Yeah, this is where I have to work on. It is this repo. If you want to look at a Python module, let me throw it in the chat. I'm starting dev.
So setup is like something like Java docs that we have, and then it creates a build that we can use it anywhere.
Yeah. So if you look at the setup py, this is where you get to set up the project URLs, the author, the packages, any binaries that you're going to create. This one's like optional. your license, your long description, which comes from your documentation, just what everything, and then what you require for the install. So that's kind of like the setup file, and then you run a Python command to go ahead and package it. It creates everything in a distribution directory, and then you use another command called twine to upload to PyPy that distribution.
And what's the format for the distribution? Like, what is the format of the file that's getting created?
I think it ends up being a TGZ.
Okay, so zip file only.
Yeah, it's a special zip file format that is used, because what ends up happening is, oops, let me see where it go. If I can type. So you can, the format is set up so you can run a pip install. And I think on the back end, that on the PyPy side, these are TGZs, the way they get stored. So when what ends up happening is it ends up being just like any other Python module. You can do your import, you can do your pip install, all those things. It'll act just like any of the other Python modules that are out there. There's just a specific directory format and setup that we need, and from there you're good to go.
Similar to a jar file, like the jar file basically a zip file only. So just
Yep.
when you basically importing that, you're just unzipping it and importing the respective classes.
Exactly. So if we look at this workspace, oops. There's the bin directory. So here is the actual module itself. And in it is a couple files. You have an init, which is basically just like a placeholder to say that this is a module. And then the PYC is the compiled version of that. And then here's the actual module itself. Basically, it's you do your Java. It's like Java doc, but it's Python doc. So you can do your doc inline in the code, and then there's ways to export it and create markdowns automatically from your code. So you do your imports, and then you just have your definitions. So like this one is being exposed, and here's the arguments, kind of like just like in Java doc, what you're looking at as parameters and your return and things like that. So that all is where it comes into play. There's a little bit more to creating a Python module than like the Flask or the Fast API, just because it requires more documentation, because it wants every single method or function documented. And then what ends up happening is once we run that that markdown code, we get our markdown file. Come on, preview. For some reason that turned on. There it is. So you end up with your Python markdown. Comes in pretty handy, you know. It's trying to give you the self documentation from the code base. So ours, ours won't be, and here's like the distribution directory. I don't even know what they're called wheels in the Python world. And I think it's just like another form of a TGZ format, but basically it's packaging it up and you upload the wheel to PyPy then through using Twine. Let me know if you're I'll get us started, and then I'll help whoever needs wants to work on that stuff, what you need to do. There's a couple command line programs like the PyDoc Markdown. There's Twine. There's the setup program. There's a bump version. So there's a bunch of little things that you need to kind of have in place to run in order to do everything. Now we can also do all the builds and uploads through our Google Cloud build jobs as well. So we can move all that over there as part of the process. Right now, these things change so infrequently, I just do it manually for this library. Any other questions? Ukarsh, did that answer your question? I think we got a thumbs up from him. All righty. Well, thank you everybody for hanging on for the extra half hour. And we'll keep plugging away. I'd like to try to wrap up the microservices this week so we could actually, we know that we are all, or at least by Monday, that we know that all the microservices are running correctly in the Docker containers, and then we can go to the next step of getting all of our Helm charts updated and pull together that last piece. So that's kind of where we're at on the project. So thank you everybody for all your hard work on this. All right. Have a good night.
Sure.
Good night, Steve.
Good night.